Hey, you found me. All right, we're talking domain and range, but today we're looking at those real world problems. So here's just kind of a process, kind of what you should think about as you tackle word problems. Okay, first you want to think independent versus dependent. Which one affects what happens to the other piece, right? So independent affects, it determines your dependent. So we're going to look for those. We're going to see if we can create that equation that goes for it. That'll show me a lot about, can I interpret the words mathematically? We're going to see from that equation what part of the story do those variables represent. Then we're going to ask ourselves, is this situation discrete or continuous? And you're like, I don't know, because I don't know these words, Miss Valente. That's okay. Discrete means not all values are counted. So not all values are counted. What does that mean, right? Like, what are you talking about, Ms. Valente? Lots of stuff. I'm talking. Okay, discrete. So not all values are counted. So if we were talking about values like people are, you're either a person or you're not, right? Like, we don't count half people. If I'm inviting a group of friends over, I either have 5 friends over, 10 friends over, 1 friend over. I don't have 2.5 friends come over. And no, we're not dismembering anybody and counting them as part of a person. Okay, they're either a person or they're not. So either we have the whole or they don't. That's discrete. Okay, if I'm paying for something and I'm buying like several of something, that's going to be discrete because I'm paying that certain amount for each one, right? So that's discrete. Not all values are counted. Now, when we talk about continuous, then continuous means that all values, and I'm going to say in between, are counted. Okay, so we're discrete, only some are counted. Continuous, all the values are counted. So if I'm talking time, right? If I'm going running, I could run for an hour, I could run for 45 minutes, I could run for 30 minutes, right? It could be any amount of time in between. So continuous, everything counts. Discrete, only certain numbers count. On a graph, discrete is the dots. On a graph, continuous is a solid line. It's connecting every value in between. Okay. All right, so we're going to look for that, and then we're going to use a table to help us identify. We're going to use that to work things out. Okay, guys, let's look at some examples. See, put this all into action. Naima invited 5 friends to go to Six Flags with her this weekend. Woohoo! Unfortunately, no one has season passes, so they'll have to pay the sale price of $54.99 per person. Sale price, woohoo! All right, so $54.99 per person. First thing we want to know is what's our independent and what's our dependent. So which piece of this story affects the other piece? Here's a big hint. When I'm reading this, $54.99 per person, if you see that per something, usually this something is your independent quantity, right? Because the number of people is going to affect the cost. The number of people determines the cost, right? So we have people determines cost, right? So that means that independent, this is my domain, and the cost will always, this independent is always my range. Okay, so if we can figure that out, woohoo, like the battle's almost won already, and like, whoo, not so much to stress out about. All right, so people determines cost, people's independent, that's my domain, cost is my range. All right, write an equation to represent the total cost y for x number of friends. So total cost y equals, it's going to cost $54.99 per person. Per is multiplication, so per person we're going to do times x is said to let x be the number of friends, right? So this is friends, this is total cost. Okay, so I want to know what all these pieces mean. If I know the language, then math isn't so complicated and mysterious. All right, next it says, what does the domain represent in this situation? Well, we already said domain is our people because it's the independent, so it's our friends. Now we have to ask this question, discrete or continuous? Okay, so when we're looking at discrete versus continuous, remember discrete, only certain values count. Continuous, all of them count in between. So discrete is people, because she either brought 1, 2, 3, 4, 5 friends or not, right? She didn't bring 1.5 friends. So this is going to be a discrete situation. And so now we have to figure out what the domain is. Well, domain is the friends, and she's bringing 5 plus herself. Okay, don't leave her out. She's included. So it's either one person goes, 2, 3, 4, 5, or 6, right? Either all the friends go, just Naima goes, 2 people, right? So 1 through 6, that is our domain. All right, what is the range? Sorry, let me go back up here. Domain is our X values. Range is the cost because it's our Y values, it's our dependent, right? Okay, so the cost is also going to be discrete because it's $54.99 per person. So we don't pay anything in between. It's not like I got somebody in for like half price or for like 10 cents and some of them paid full price, or every single person is $54.99. And so this is why I like that if I know my equation, if I know the pieces, then I know, okay, I have people, and that would be my X value, and I know my cost is Y. And then I can just fill in if there's 1, 2, 3, 4, 5, or 6, what is our total cost? Okay, I would just use my calculator, right? I know one person is going to be $54.99, and then use your calculator and figure out the rest. So I'm going to pause real quick, and then I'm going to fill it in, and then we'll talk again. All right, so I plugged into my calculator, just doing people times cost, right? So 2 people, $109.98, 3, $164.97, so on, so on, so on, right? So if they all go, it's $329.94. So notice this Y value, this is my range values, and it's discrete, so it's only those costs. It won't be paying anything else. So for our range, we would list each of those values, right? Because we're showing each of those is what our possibilities are, whether if it's just Naima who goes or up to all of them going, right? So I'm just going to list. I feel like elevator music should be playing right now while I'm writing all these numbers. And notice they're always listed in these brackets. That's set notation. That's how we have to write it mathematically. It shows like this is a set of numbers to represent it. Okay, so that's domain and range from our first real world problem. Let's try it again. Here we go, round 2. Dylan wants to go mountain biking. The local bike shop rents bikes for $4.50 per hour, plus a $10 deposit. They want to make sure they get their money, guys. Okay, Dylan plans on spending between 3 to 7 hours exploring the trails on his bike. All right, so our first thing is, what's our independent, right? So independent determines the dependent. So we're figuring out what piece of the story affects the other one, determines what happens to the other one. Remember what I said? If you see that per something, hey, there's per hour, that's telling me there is my independent, because the number of hours I rent for determines my total cost. So there we go. We have our hours determines cost. Guys, if I know this, I already have found my domain and my range, like quantities. I know what I'm looking for to find those numbers, right? Okay, so write an equation that represents the total cost Y for X number of hours. So if I do our total cost equals, and then I'm going to come and I'm doing just what this says. It says it's $4.50 per hour X, right? Plus, hey, do what it says. It says plus $10 deposit, so plus 10, right? Just read it as it is, that per hour times the number of hours, right? So we have cost, we have our hours. All right, what does the domain represent? Hey, we already figured that out when we did our independent and dependent. So this is hours. And so is our number of hours discrete or continuous? right? He wants to go from 3 to 7 hours. Could he go 3.5? Yeah. Could he do 4 hours and 5 minutes? Sure. Could he do the whole 7? Yep. So this is going to be continuous because that time could be anywhere between 3 to 7 hours. So to show that, when it's continuous, we use inequalities, right, to show our domain. So our domain, I go the left, the lowest, right? So it could be 3 hours. It could be all the way up to 7 hours. And so our time, our hours, is between the lowest and the highest value for our domain. Okay, so there we go. That's our domain. Now it says, what does range represent? Well, if domain was hours, range has to be my cost. Okay, and this time we're not going to overthink it. We're just going to go with it. $4.50 per hour. So we're going to say that they'll charge us, if we go 3.5, they're going to do 3.5 hours times 4.5. So this could be continuous because it could be any of those costs in between, right? Okay, so now how do we figure out exactly what the range is? So this is where we use our table, right? I'm just going to set it up real quick. So we have our hours, which is our domain. And we have our cost, which is our range. All right, we said it's continuous. So continuous, I want to know what's the lowest and then what's the highest because I know my cost is in between those, right? So he wants to go either 3 hours. I'm just going to do dot, dot, dot. Or he wants to go anywhere in between 3 and 7, right? And those are the only costs I need to figure out since it's continuous. So if he does 3 hours, it'd be $4.50 times 3 plus the 10. Whoa, don't need that mark. Okay. Oh, okay. If he goes 7 hours, it's $4.50 times 7 hours plus 10. Okay, so let's see what those equal. All right, so using my calculator, I can figure out 3 hours would be $23.50, and 7 hours would be $41.50. So to write that down here, being crazy. Remember, we go the low. Gosh, I can't talk, guys. So our lowest price would be $23.50, and it's or equals to because he could go just 3 hours, right? Y is our cost, and he could go all the way to 7 hours, which would give us $41.50. So range is the cost, Y in between, or equal to because it could include those. All right, let's look at one more. It'll take a truck driver no more than 20 hours to travel from the warehouse to the store to make a delivery. The truck driver began driving with 200 gallons of fuel in the truck's fuel tank and used fuel at a rate of 10 gallons per hour. All right, independent versus dependent. Do you see it? Do you see it? Oh, look, there's that per hour. There's our independent because the number of hours he drives is going to tell us how much fuel is left. All right, so hours determines how much fuel is left. Okay, so if we write this equation, we have the fuel left is Y equals, and after our driving, so we need to figure this out. We're going to write it a little bit different because he started with 200 and then he used tells me subtract, right? So I'm going to subtract 10 gallons. So we're going to subtract 10 per hour, right? So the domain represents the hours. This is continuous because it could be anywhere from 0 to 20 hours, depends on how long he drives. So it could be anywhere between 0 and 20 hours. That's how we would write that. Remember, this is our hours, and it's in between the low and the high. Okay, range represents the fuel left. That's also continuous, right? And so that's going to be either the low is he runs out of gas, all the way to the high is he didn't drive at all. And that's where we are, okay? This is our fuel left. That's it, guys. Let's see what you can do.